Hello guys, today we are going to model a simple frame structure. I'm going to introduce what is a frame element, and we are going to model a simple frame structure like a truss. We can get it from this Sap software itself. So let's see what is a frame first. If we check the internet, we can see the frame element has 6 degree of freedoms per node, which means 3 translations and 3 rotations in the 3 directions. So as you can see there, we have 3 translations for x, y, z directions, and also 3 rotations on those same directions. So this is the frame element in SAP 2000 also. So let's create a new module. Let's go with like 2D truss. We can, or let's go with the beam, that is easy. So okay, let's say number of spans is 3 and this 6. Span length, let's take it as 3000 millimeters, that means 3 meters, and beam. Okay, so here we have the beam element. We can do it like this, and this is a pin joint, and these are roller supports, which we can say this is a simply supported beam with 3 spans, which 3 meter span length. And now we can assign a section for this beam. Let's create a new section. Let's go for concrete structure section. So here concrete, and we can choose rectangular. Since we are using the kilonewton millimeter units, we can define this with millimeters. So let's go with 9 inches depth, that means 2 to 5, and the width also 2 to 5. So, and we can define the material here. A new material, let's go with Euro codes, concrete and grade. Let's go for 220. Okay, so we have defined the material has C2025 concrete grade and the depth and width. And let's give a name for this beam 9 by 9 or 2 to 5 by 2 to 5, and we can give the reinforcement here, concrete reinforcement, and we are designing this as a beam, so we just need the M3 design only. So we can give this, and we don't need to change it because these are rebar material, and concrete cover to longitudinal rebar center. So let's say we are having, like, we are supposed to have 16 millimeter reinforcement, and we need to have 30 millimeter cover. Then we need for the center we have to get 30 plus 8, that means 38. Let's put 38 for both. Okay, now we have this beam. Let's assign this frame section to this beam. Okay, now this frame is assigned for this section is assigned for this frame, and you can see the 3D view of this one. Let's see the extruded view. Okay, so you can change the color of this extruded view also. You can fill the object. You can view colors by the section or the material, and also to change the color of this section, you can add extra color unit. Let's set like this color, then define this by section. So this will get the section color. You have to select this 3D view. Okay, so we have the simply separated concrete beam. Now we can have the 2D one here, not the extruded one. Let's go for the standard one here for the modeling purposes. Now you can define the load patterns. Right now we have the dead load, then you can define a super dead load for the extra dead loads you are having. Also we can define the live dead load. Let's say this the beam live, anything you want you can type here, and you can choose the load type here. Okay, let's add this one also. Okay, so now we have 3 load patterns, so we can add different kind of loads here. Let's add like assign frame loads. So we are applying line loads for this frame, because we can't apply area loads for this frame directly, because this is a frame element. To add area loads, we need to have shells or like elements with areas. So this is the uniform load units, kilonewton per millimeter. So I can change this to kilonewton per meter, which is easier for me. Let's add a beam SD load in load direction gravity. Let's add 15. Okay, so the gravity means in the direction of Z, opposite of the direction of Z. So we apply the frame loads to the beam. Also we can add some live load. Let's add until like 20. Yeah, so when we add live load, this window shows the beam live. This is 20, so we can check display element object load frame, and check what type of loads we have assigned here. See, 15 for dead load, super dead load, and for the beam live we assign 20. Then we can define the load combinations here. We can add default combinations, or we can add new let's go with default design combinations for concrete frame design. Set load combinations. Okay, so they are defining 3. So this first one is 1.35 dead and 0.98 beam live, and the next one is 1.2 dead, 1.4 beam live, and the next one is 1.0 dead and 1.4 beam live. Okay. Okay, so now we have drawn the frame, and we have defined a section for the frame. We have applied the load for the frame, so now we can analyze the frame. So let's click this run analysis button. Yes, you need to save this one. Okay, now we are having the deformed shape for dead load. also you can get the bending moments, uh, these load combinations, and this is the axial force. This should not have any axial force because this is simply supported beam. So let's go for moments. So these are the moments. If we, these are the values with kilonewton kilonewton meter with net unit. If we go for the shear, and these are the shear loads on the structure. So we can check the other side also, and it should be 0 if we did it right. So we only have moments in three direction and shear into 2 direction. Let me explain what is 3D direction. We can see the directions here. Let's see the local axis. Okay. So we can see there are 3 local axes mentioned here. Let's see. Local axis colors Sap2000. So the axis 1 is red, axis 2 is green, axis 3 is